company. So there's a bit of a transition, and we can talk about that today. I've been in the robotics industry for about 17 years now. If anybody knows AvidBots or Arion Labs from many years ago, which is now a FLIR company. I started at both of those companies before I was the first sales and business hire at those organizations. So I learned a lot about the journey of going from a pre-seed, early stage, no revenue, small robotics or hardware company, and all the way up to scale and size and global dominance. So that's my journey.
Kyle, co-founder of Intaline. We make probably an engine you've never seen before because it's a new architecture from scratch.
It's very cool.
It's an opposed piston engine meant to replace the traditional industrial diesel generator that runs on any fuel. A lot more. We've been working on it for just about 5 years now. I started at right out of university, so a few years in mechanical engineering, dropped out, started Intaline, and here I am. Learned a lot along the way, namely because we also make pretty much all of it in-house. So we've made quite a variety of parts for that. We're also just starting to get into some automotive, like aftermarket performance parts as well. So I like making stuff. It still keeps me busy. It's definitely very exhausting, but I would rather be good at it.
Amazing. So I guess you guys are wondering where the heck you guys are right now. So this is the hello. This is the Sienci Labs headquarters. Here we are aiming to make Sienci manufacturing more accessible. Wow, this mic stuck. Hello.
There's another one.
Okay. Hello. Hello. We're trying to make Sienci manufacturing more accessible. And so this is like our headquarters. We build a ton of Sienci machines here. This is kind of like our inventory space. This is where we ship all the machines out the door. So there usually comes a truck. We put all the machines back there. And yeah, you can't really see the assembly space, but if you go all the way back there, and we're gonna have a tour later, that's where we build all the machines. So yeah, thank you guys for coming. Yeah, so I guess let's start off with like a really broad question. What do you guys think makes hardware hard? Like, what makes hardware hard for you? You go, Hawaii.
Okay, well, yeah, I think hardware is not hard. Well, it's only hard at the beginning, but then very easy afterwards. That's what.
I have a different thought on that. I think hardware is hard, but it's right. It's hard at the beginning. It's expensive. In my own journey, when I left the last company, and thought I feel like I'm talking like I'm Liam Gallagher from Oasis, way up here. Is better. So when I left the last company, I thought I knew everything about the robotics industry and the hardware space, and it was just going to be simple. Anybody can start a robot company, go ahead and do it. Turns out it's really fucking hard to start a company. It's really hard to start a robot company. One of the things I learned was there are so many, at least in our experience, there's a lot of failure, even with the best of people. There's a lot of failure that we went through, and that failure costs money and time, and that means you need to have that runway to be able to do some of that work. So that was the journey that I had, and that's why I say robot or hardware is hard, but it also depends on what you're building and how complex that product might actually be.
There we go. Yeah, I think that it's a mindset. Satisfied here. You know, when you're starting out, you're on a level playing field with your other startup that's begging for money from some VCs. Right? Like you're all in the same boat. You're still there to maybe sensible business plan for an investor and show, why you have the thing or people want it, right? And to get to those initial stages where you're showing some traction, you have to have kind of done something first. And in the case of hardware, that's creating something physical, which costs a lot of money. There's really no way around it. I think in those early stages, it amounts to you have to do the impossible. You kind of have to run through a brick wall and just somehow do it. On one hand, it seems unfair, but on the other, I mean, plenty of examples to point to of it happens, and those who do make it through that killer first stage and do the impossible, well, that's a bit of proof on its own to the investors that you can pull off this really, really difficult thing. And I think that's where the easiness starts to kick in a little bit, where you've sort of proved yourself, you've got something real, it's tangible, it's not just a fad. There's a little more stability in that. That's about as friendly as it gets. Beyond it's endlessly compounding complexity.
I think maybe they're interfering. So we'll just use the blue ones.
One on.
Yeah, just use the blue ones.
Hello. Cool. Sorry. Complexity does compound as you get further and further into the business. So when you're starting out and making progress, you need to make that MVP. It just needs to work and do this one thing. That's it. But now you need to make 10 of them. Now you need to make 100. Now you need to make 1,000. At every step of the way, it's not necessarily just the same problem. Like, oh, I just need to make 1,000 products. Like that alone is a whole new development of hardware challenge. You need to build your supply chain, develop the machines if they're a specialty, to make every single component. Every single component needs to be quality checked. Every single component is going to have some weird long-term failure. So these are like all the layers and layers and layers of stuff that come up that you have to deal with that a software company doesn't necessarily need to. You're still fighting the same level of problems. There's going to be bugs. There's going to be additional complexity. Your customer base is growing. But they can test and iterate a heck of a lot quicker than you can with something physical. So the thing is, like, I think a lot of people like to point to, oh yeah, you know what, hardware company. It's like, you know what, it's all a business. It's all a level playing field. Don't make excuses. Treat it the same way. Hold yourself to the same standard as any other company would. Just get really, really, really good at how you mimic that sort of iteration and solving bugs as a software company would. If you can get really good at that with the physical things, well, I think that's the hardware companies that actually win.
I have one more thought. I have one more thought on that, and it reminded me of some PTSD that I had from Avidbot's days, which was the product. When I joined the organization, there was V1, and that was a product that was designed in somewhat piecemeal with a lot of like Alibaba parts just to make it all work. And then it worked, and they gave it to me, and I went out and sold it to the world. And then we started to get into hardware debt, which was a piece of equipment that the first 10 robots, they all had names. We knew the names, and they didn't have the engineering discipline around them that we wanted. So that was a red wire, and that was a blue wire, and that was a green wire. And then when you get into the field and it breaks, we send somebody from this part of the planet who just joined the company, who's never grown really fast. That guy, he looks at the document, he's like, it says there's a red wire, and this looks like a green wire, and I don't even know which was the red wire. We didn't know. So we had this hardware debt challenge, which was as we sold more robots, that was never designed to be a production product. But people liked it and wanted to continue to buy it. We had to quickly iterate and engineer a new piece of technology that was production ready and more scalable and fought the concept of scale in production and manufacturing. At the same time, the hardware debt was that customer is not going to buy another one, so we got to keep them going. And that's the guy that actually was the first important customer that bought that really complicated thing and put all that weird energy in this tiny little company. And so we got to treat them like gold. So that hardware debt becomes a problem for at least it was for us as a hardware company, until we could get to that stage where we could go back to those customers and go, hey, I got a great deal for you, free robot. Just get take the new one so I can take this old one and throw it directly into the garbage just to get it out of my ecosystem, because it was such a pain in the butt. That hardware debt they had, that's PTSD for me in my mind.
Should I also? Okay. Yeah, I can definitely echo the issues. I have some radical views on this. So the way I see it, the reason it's hard because a lot magnitudes more people are involved in the supply chain, right? So when you have software companies, it's automated a lot more. Maybe you have, let's say, 1,000 people that continuously, and that's in your supply chain, but maybe a million algorithms that's running. But for a hardware company, the supply chain could be 5 million people, right, around the world. And to rebel against the kings, organizing 1,000 people is a lot easier than organizing 5 million people, right? The complexity of human organization grows exponentially, while the payoff grows linearly, right? So look at UK, for example, you have the Camelot, you have just a few people, and you can do great things. But if you're in China, it's millions of people that dies, and nobody remember which war they died in, right? It's similar in that sense that you need very sophisticated organizational skills to be able to control all of the 5 million like little screws, all the washers, like everything, all steel from China is just rust. Stainless steel not supposed to rust, it rusts, right? And because somebody touched it with their hand after some process, right? So it's very hard to manage.
Yeah. So yeah, to echo some of the sentiments here, I think one of the things hardware doesn't allow is with software you can copy and paste, and you can copy and paste as many times as you want. But in hardware, you make the same thing, and it's going to be different every single time. So I have a prof, Professor Chat. I don't know if a lot of you guys are from University of Waterloo, but he was my electrical professor, and he said this like very profound thing, which is like in engineering, it's not 2 + 2 = 4. It's 2 + 2 = 4 plus or minus a tolerance. And yeah, we here make a lot of CNC machines, and every single time we make a batch, there's always a new challenge or a new problem, something that affects the quality control of the machines, and we always have to solve new problems. And yeah, like as Huawei was saying, building 100 machines, that's one challenge. But then when you need to make 1,000, the challenge also goes up exponentially because you have so many more people. Maybe you're dealing with more suppliers and manufacturers. We had a really interesting problem crop up, which is hydrogen embrittlement. So for people who don't know, when you make screws, you can coat them with different things so they don't rust. So you can use like oil, or you can use zinc plating, or you can coat them with paint. There's a lot of options. And when we do the assembly, we have someone like physically take the screw and put it into the machine. And with the highest grade of screw, the strongest version of screw, they're usually coated with oil. And we need the strongest screw to use for the assembly, but they have oil, so then the oil gets on the parts and it makes it look bad. And also the people handling them don't like the oil. So we're like, oh, why don't we just like zinc plate them? Well, it turns out when you zinc plate the screws, it introduces hydrogen into the crystalline structure, which causes it to become brittle. So even though we're buying the screws and we got them zinc plated, as soon as we started assembling them, they would just shear and snap. And, this is just like really obscure chemistry, materials thing. And that just like fucks up the whole like assembly process. And it's not just that. We didn't discover it right away because you would screw it and then it'd be fine. And then when you have to go back to torque it, maybe like a week or a couple months later, that's when they start snapping. So like bug fix. This is not a bug fix that's easy to implement, especially when the machine might be somewhere on the other side of the world. So I definitely share those sentiments. But yeah. So another thing that I heard several times is the money aspect. So I think all of us had a different funding journey, I would say. I know, Kyle, we were talking earlier, and you were telling me about waiting on some funding to come in, maybe I could start with you. Maybe you could talk about your fund. You can talk about your funding journey and how that's been.
Sounds good. So let's see, I've been at it 5 years. We went through Y Combinator originally, and really just nothing more than I need at that stage, and the lovely render of here's the concept, here's what it'll look like. So I'm eternally grateful to the angel investors who betted on us at that stage, and they're great people. They understood hardware. They're in it for the long run. So thinking like way back to those very first early steps. I mean, we've done the pitch competitions at Waterloo. So awesome that those exist, because I mean that's just that little bit of capital to allow you to do something and get going. But then, yeah, of course, if you're wanting to build some real prototypes of an engine, that's getting into some serious money. Yeah, so the one thing is like there's a ton of investors. Y Combinator's great, lots of attention on you to like kick off the the FOMO, really get the ball rolling when you raise a round. But of that investors, there's a much smaller subset that actually understand or are willing to invest in hardware. And of those who are willing to invest in hardware, there's an even smaller subset who like really get it. They know that their return is not happening in 2 years or 3 years. It's happening in more like 10 years. And they're in it for the long run. Those are definitely the investors you want, because you do need good investors to make the intros, to understand what you're doing, and kind of help point you in the right direction because they've seen it before. So yeah, even though it is a smaller pool to choose from, I'd say when you do find the right people, the quality can be much higher for those hardware investors. So anyway, yeah, raising seed round, raise a bit of money. Even during that whole process, though, you're still getting asked this of like, why don't you just do an MVP and give it to a customer? Well, an MVP of a combustion engine on a nothing budget, pretty sure that's on. So safety is paramount. That's never something to let go of in engineering. Investors are looking at it from the money perspective and assuming you'll figure out the safety part, right? So it is constantly about, they want you to do the impossible. You want to do it right as the engineer, and you have to find somewhere in between where you make no compromise on safety, but you do get an MVP out there that demonstrates the critical features that the investors need to see to give you money. You may have some grand dream in mind of like, this is what the amazing end goal will look like, and I'm sure that's very possible, and it probably takes you $100 million to get there. You do need to break it down into pieces and say, okay, wherever the money is going to come from at the next step, how do I demonstrate something and get to that? It may be, in the grand scheme of things, kind of inefficient and a silly way to engineer things. Like the engineer in you is probably looking at it saying, if I just had the money now, I could do this whole thing way faster, more efficient. And that's what the investors want, right? That's great. That is what they want. They don't actually understand that's what it takes to do it, though. So you kind of have to deal with reality and break it down into those smaller steps and look at what can I show off in my product that makes what I can see very clear to the people with the money. And then when you're all on the same page, some magic can start to happen, right? I mean, really, when you think about it, anything you do, it's just communication, right? Whether I'm talking to you, explaining something, or if you see my product, or anything I can use to explain, all I'm trying to do at the end of the day is I have an image in my head that I can visualize, and I'm trying to put that into your head. That's what you're trying to do with the investor, because you believe in this thing. You're so passionate that you only bother doing it because you believe this is the future. And why work on anything else? This is it. This is what matters. The investor doesn't see that yet. If you can put that image in their head and they get it, okay, great. Now you're sharing